Okay, so here's the fourth video, everyone, in our general maths self-paced learning task. This is the Chinese postman problem. Okay, so this postman needs to deliver letters to every house, and the houses are on the streets, which are like the edges of a network. So that means you have to travel each edge in the network once. Now we want to minimize the distance of the travel. So in this network, if we could find an Eulerian circuit, that would be best, because then the postman would only have to travel each street once. However, if we look at the degree of vertex G and D, they are of degree 3, which means we have two odd vertices. Now, okay, we could have an Eulerian path, but that's no good to the postman, because the postman would end up in a different spot to where he started. So we need to figure something else out. So no Eulerian circuit's possible, and an Eulerian path doesn't work for us. Righto, so the way to do this is to look at those vertices of odd degree. The fact is we need to travel between them twice. So G and D, those vertices of odd degree, need to be travelled between twice. So let's see. Is it better to travel twice along this side, which adds up to 13, or along this side, which adds up 6 and 6 is 12? Well, clearly 12 is shorter than 13, so that's the best one to do, to go along between F twice, D, F, G twice. So we do something like this. Let me give it a go. Alright, so we'll call A as the depot. Okay. So we're going to go this street and this street down to here, then we'll go this way, this way, this way, this way. Okay, now we're not going to go back through E, we're going to double up on this edge and then head back to A. So doubling up through F. And if you add up all those numbers that we crossed, it adds up to 95 kilometres. So let's try these ones. You might want to pause the video and try that on your own first, then I'll have a go at it. Right, so the vertices of odd degree in this first one are C and B. So we need to travel between them twice. Okay, let's have a go starting at A. We'll go down to B, up to E, over to here, to C, to D. That's no good. I'll try that again. Try it this way. We'll go down to B, across to here. Then we'll go up, down to here. Okay. No good. Bear with me, I'll get it. Starting at A, down to here, across to here. Yeah, okay, do that. Now, is it best to travel back along this side here, along the 6, or go 2 and 2? Well, the 2 and 2 only adds up to 4, so it's best to go along these two sides, and that'll add up to 4, so we double up through E rather than going directly along that one. Finally, I got it. Then we go up to D, back down to E, and up to A. So that route was A to B to C, to E to B, and then we went back to E, to C, to D, to E, to A. So that's 6, from A to B is 6, B to C is 6, adding up all these edges, then 2 plus 2, and then that again, and then we went back to D plus 6 plus 3 plus 3. So the answer we get here, 12 and 8 make 20, 26, 32 is the minimum for that first one. Okay, so let's move on to the next one. Now in this one, where are our odd vertices? We've got odd vertex at C and B. Those are our odd ones. So we're going to have to travel between those two twice at some stage. Okay, so let's give this a go. Let's go all the way around to B, back around to D, over to C, then down to E to F, back up here, and then we'll go up to B. Now, the question is, should we go down to back through this way or go to A? Let's try going to A to C, and then I think back to A is the best way. Now, we've doubled up on this edge and this edge, and the reason for that is because we could have gone through this way, so this edge and this edge, which makes 9, or doubled up along this route between C and B, which is 3 and 5 makes 8. So doubling up on those edges was the best. Okay, so if we add that up, we have that 5 edge twice and the 3 edge twice. Then we've got that 8 and that 4. Then we've got this 5 edge and this 6, this 3 here, and that's 7. So that adds up to 16, 24, 28, 33, 39, 42, 49 is the distance there. Actually, it's in kilometres, I've noticed. I better put those units in for those first two. Okay, so I'm thinking 49 is the minimum here. All right. So this last one. Now, we've got 4 odd vertices. B, C, E and D. So we're going to have to figure out the best way to go past those. Okay, so we're going to start at A. Let's go round to E and D, go all the way around to here. Now somehow, well, we will definitely want to do this. Go down here. Now I think we should double up on this edge, go this one and double up on that, because it's better than going and doubling up on the 6 or the 5, because doubling up on the 2 2s makes a total of 4 on each of those, but if we doubled up on the 6, that would make 12, and if we doubled up on this 5, that would make 10. So it's best to double up on those 2 edges between the odd vertices, and then we head back around to A. So let's add that all up. We've got the 2 6s there, and then we've got those 2 2s. Put a plus there. Plus 2, plus 2, plus 2. We've done them. And then a 6, and then a 5, and then another 5. So 12, 14, 16, 18, 20, 26, 36. Okay, so there's how to do those Chinese Postman problems. Look for the pairs of odd degree vertices and try to find the shortest way between them. Okay, now you can try the questions in the book.